All right, calculus. This is kind of weird. So I recorded this video like 2 years ago and the audio is gone. So I am actually going to just watch the YouTube video, record my screen, re-record my voice. So I might have to pause it and kind of figure out what's happening. But what about two curves that intersect at more than 2 points? We've got, oh, see, this is not good. We've got two functions. F of x is equal to 3x cubed minus x squared minus 10x, and g of x, which is negative x squared plus 2x. Now, if I want to figure out where these two things intersect, we know that we're going to set them equal to each other. And so to solve this, we're going to move everything to the same side. So I moved over the x squared to get a x squareds are going to cancel, move the 2 over, factor out a 3x, and we're able to solve pretty quickly for the points of intersection, 0, positive, and negative 2. This is the places where these two graphs intersect. That being said, I still have to think about what these graphs look like. We know x cubed is a cubic function, rising. We know x squared is a parabola. In this case, it's a parabola that's opening down. Now what's interesting is I don't know what my past self was doing. Okay, we're gonna graph this function first. So x squared plus 2x, we can factor that pretty easily, pull out a negative x. I can see my two zeros are 0 and 2. Then if you want to figure out more about the parabola, we know it's opening down. That's my shape I'm showing you. It's not totally necessary to be super detailed, though if we wanted to, we could plug in 1 to get that y value. Now again, we know that 3x cubed minus 2x minus 10 is our cubic function. And in a moment, I'm going to draw that. But I think what's important to note is I can see where these two graphs intersect, which is what I was doing right there. They intersect, we already found this, at 0, at 2, and at negative 2. So I added those points to my curve. Because I know it's a cubic function that looks like it's rising, falling, and then rising, I can be pretty quickly sure that this is going to be my graph. Now I'm going to shade the region I'm curious about, the region between these two curves. I've got one chunk over here and another one over here. How am I going to calculate this area? In class yesterday, we talked about top minus bottom. The catch here, of course, is that there's a top function that changes. So we're going to have to do two integrals. The first is the integral from negative 2 to 0, where the blue function, or the cubic function, is the top function, and the green function, the parabola, is the bottom function. So the integral from negative 2 to 0 of our cubic function, f of x, minus our quadratic, g of x. And we're going to add to that our next integral. The integral, now with our new bounds, from 0 to 2 of, in this case, our parabola is the top function, and our cubic is the bottom function. So g of x minus f of x dx. Of course, we can find this by hand if we want, or we can find this in our calculators. I don't actually know what past me did, so we'll wait and see. Oh, looks like I was doing this in my calculator. Then, of course, the fastest way is going to be to add these f of x and g of x into my y equals, so I don't have to type them in so many times. So I'm starting by putting my cubic function into my y1. Then my quadratic function into my y2. And now that I know that, we can find these integrals pretty quickly using the function integral command. So math 9, the integral from negative 2 to 1. I think this might be important to go back to, sorry. To get our function, we can go to variables, scroll over to y variables, We want option 1, function. Oh, it just cut off. No! Ah! Sorry, I probably could have paused the video, but the thing that's important here, and I'm going to pause it, is we go variables, y variables, and function, and you can pull in what's in your y1 and your y2 there. That being said, I realize now that this video did not have the final answer on it. So give me one moment. When you use your calculator to go in and find that answer, we would get 24. Here I have the work actually by hand, and I will post this online if you are curious. I think it's important to practice doing it by hand, but that should be something that maybe focus right now on setting it up. The solving should be something you know, but can maybe come backseat right now.